All right, with an understanding of the principle of diversification, let's now put it into practice. So this is problem 3. We're going to calculate the expected return and the standard deviation of expected returns for a portfolio made up of assets X and asset Z. Now keep in mind, in a previous video, we calculated both the expected return and the standard deviation of expected returns for X and Z. So you have that. Now what we're going to do is we're going to put these stocks together in a portfolio and show the importance of diversification. So what we've done here is we have an extra column here that says the return for the portfolio, and what we need is to find the return for the portfolio in each economic state. Okay, so in order to get the return for the portfolio in each economic state, we're going to need to get weights for each asset in our portfolio. So part of the question is to assume 40% of your wealth will be in stock X and 60% of your wealth will be in stock Z. Okay, so I'm going to do this in Excel here on the right. Here's the return of the portfolio, that last column. And what I need to do is I need to figure out what the return for the portfolio will be in each economic state before I even begin to calculate the expected return of the portfolio. So let's do this. What I'm going to do is I'm going to take the weighted average between the returns for X and Z, where the weights are given in the question. That is, I need to take 40% of negative 2% plus 60% of 15%, and that's going to give me the return of the portfolio in the recessionary economic state. So let me do that real quick. I'm going to take 40%, 0.4 times 2%, plus 0.6 times 15, and I get a return for the portfolio in the recessionary state of 8.2%. Let me format these in percentage. Does that make sense? I need to do this for each of the economic states, and once I have this done, then I can calculate the expected return and the standard deviation of expected returns for the portfolio. So in the second economic state, I'm going to say 0.4 or 40% of the returns for stock X in that state plus 60% of the returns for stock Z in that state, and I get 12.6%. And in the last state, 40% of the returns in 40% of the returns for stock X in that state plus 60% of returns for stock Z in that state. Okay, so these are the returns for the portfolio in each economic state. I'm going to pause right here, and this is a common mistake made by students when trying to calculate the expected return of the portfolio. Notice that when I calculated the returns for the portfolio in each economic state, I didn't touch the probabilities. I have to get the returns for the portfolio in each state with the weights that are given, the portfolio weights that are given in the problem. Once I've calculated the returns for the portfolio in each economic state, then I will use the probabilities of the different economic states occurring. So the expected return of the portfolio is going to be the probability of the first economic state times the returns of the portfolio in that state. I'm just working on this formula here. The probability pi times the returns for the asset in question, in this case it's the portfolio of X and Z, plus the probability of the second economic state times the returns to the portfolio in that second state, plus the probability of an expansionary state times the returns to the portfolio in that state. And I get an expected return of 12.9%. Let me format that in percentage. To calculate sigma of the portfolio, I'm going to use this formula here. And I'm going to say equals the square root of the probability of the first economic state, that is pi, the probability of the first economic state, times the squared difference between the returns for the portfolio in that state and the expected return of the portfolio that we just calculated. So probability of the first economic state times the returns to the portfolio in that state minus the expected return squared. All right, so I just calculated that formula right there. I have to do this for each of the states, and I have to sum across states, so I'm going to add the probability of the second economic state times the squared difference between the returns for the portfolio in that state minus the expected return squared plus the probability of the third economic state times the returns to the portfolio in that state minus the expected return squared. Let me close my square root bracket. Hopefully you can follow that formula there. Just using the formula there on the left. I'm going to hit enter. I get a sigma of the portfolio of 2.43. What's interesting is we can now compare the performance of the portfolio as well as the sigma of the portfolio, the standard deviation, to the expected returns of x and the expected returns of y, as well as the standard deviations of x and y. And what you're going to find is relative to the level of volatility, which is actually similar between asset Z and the portfolio, the volatility is the same. You get a much higher expected return. So this is I think important. This helps us understand the principle of diversification and how diversification can actually improve our investment decisions or improve our investment outcomes once we adjust for risk. Once the risk has been reduced, we might get a higher return on a risk-adjusted basis.